Bismillahirrahmanirrahim. Alright class, Assalamu alaikum. Okay, so today we are going to discuss few of the problems which students are having trouble in, and today specifically we are going to discuss drill problems of chapter number 3, that is the chapter belonging to electric flux density and Gauss's law and divergence. So specifically if I talk about drill 3.1, so drill 3.1 gives us a charge of 60 microcoulombs. So this is quite straightforward, and it is located at origin, so 0 0 0, and it says that given a 60 microcoulomb point charge at origin, find a total electric flux. So we are talking about flux, remember, psi, not d, not flux density, passing through part A. Portion of the sphere are 26 centimeters, bounded by so and so and so and so. So r is 26 centimeters and theta is from 0 to pi by 2. Maximum limits of theta are 0 to pi, and phi from how much? 0 to pi by 2. So specifically what we are talking about a sphere which is lying on the first octant. Okay, so actually if this is the first octant means x positive, y positive, z positive, because phi is from 0 to pi by 2, meaning from x-axis to y-axis, and theta, which is measured from z-axis, from 0 to pi by 2, means from positive z-axis to xy plane. So but since phi is from 0 to pi by 2, it means that we are not interested in a whole of the xy plane, rather that portion of xy plane where values of phi are from 0 to pi by 2. So means that this is the portion of the sphere r equals 26 centimeters, through which the quantity of flux which is passing, we are interested in that quantity, and this charge 60 microcoulombs is located at origin. So this problem is quite trivial, just to reinforce your concepts of flux. So whatever flux is leaving, this charge should be equals to the amount of charge itself. So this flux will emit in all the direction uniformly in a balanced manner. So excuse me, had this point charge been covered by a whole sphere, let's say this point charge at origin is 60 microcoulombs, had it been covered by or enclosed by a complete sphere, the total amount of flux which will be crossing this sphere would be the total charge enclosed by this imaginary sphere, which is equal to 60. But we are not interested in the whole sphere, rather we are interested in 1/8 portion of that sphere. So definitely the flux crossing the 1/8 portion of this total sphere would be equals to the total flux which would be crossing had we considered a complete sphere enclosing the charge 60 microcoulombs. So this would be the flux which would leave this complete sphere, but we are not interested in that, rather we are interested in 1/8 portion of that. So definitely 60 divided by 1/8 is given by is actually 7.5 microcoulombs. Okay, so this is part A. Part B says that we have to find the flux. Closed surface defined by, okay, now this time we have got a closed surface which is defined by a cylinder whose radius is 26 centimeters again, and it is capped from the top by z equals 26 and from the bottom by z equals minus 26. So obviously this flux, this surface in part B, which surface, rho equals 26 centimeters, z equals plus minus 26 centimeters. These three planes, these three surfaces are defining a closed surface which is enclosing the total charge which is present at origin. सारे का सारा चार्ज इस closed surface के अंदर बंद है, so उतना ही flux यहाँ से निकलेगा. So the amount of flux leaving this surface will be equals to the charge enclosed by this surface. So in this case the answer would be 60 microcoulombs, because this surface rho equals 26, z equals plus minus 26, this is enclosing whole of the charge which is located at origin. Part C, the plane z equals 0. So now this time we have got x, y and z, and at z equals 26 we have got a plane. So definitely if this is, and we want to find the flux which is crossing this z equals 0 planes, and this z equals 26 plane, sorry. So z equals 26 plane is infinite plane. It will go up till infinity on the right, on the left. So the flux which will be emitted by this this charge, half of it will go up and half of it will go down. So all the portion, all that portion of flux which is above z equals 0 plane will definitely cross z equals 26 plane somewhere. Even the flux line which will be approximately parallel to y-axis will intersect this z equals 26 surface somewhere at infinity maybe. Okay, so half of the flux will definitely cross z equals 0, z equals 26 plane. So the answer in that case would be 30 microns. Okay.